Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Nadia Safitri and PM 2020-022046 Basic Education Program Study, University Lampung. How are you today? Hope you always healthy and keep up the spirits. Even though environment does not support you to study at school, don't forget to take the time to study at home. You ever heard the story of the famous scientist Sir Isaac Newton, who fell from an apple? Well, once upon a time, Newton engrossed in sitting under an apple tree. Accidentally, an apple fell on his head. From this simple event that Newton managed to find the Earth's gravitational force. The material we will discuss in this video is not its gravitational force, but the motion that the apple has. What motion is meant? The apple that fell on Newton's head was in free fall. Why is that? Because free fall motion, are commonly abbreviated as TJB, is motion that is only affected by the Earth's gravitational force, that is other force and force can be ignored. The main condition for an object to experience free fall motion is that the object's initial velocity is equal to zero, or the object is moving without its initial velocity. Motion is example of straight change in order, or GLBB. If you pay attention, the direction of free fall motion is always in same direction as the gravitational acceleration. Therefore, free fall motion, including GLBB, is acceleration. In the direction of the object experience free fall motion in the same direction as the Earth's gravitational acceleration. The acceleration of the object is the same as the Earth's gravitational acceleration. The trajectory is a straight line. To increase your understanding of free fall, consider the following image.
From this figure, it can be seen that the length of time an object is in the air. The air is only affected by the height, and acceleration to gravity or no other quantity is affected. For example, if two objects have different masses and both fall from the same height, then the travel time of the two objects will remain the same, or in this case, our friction is neglected.
The previous discussion we discussed the condition for free fall motion, namely the initial velocity is equal to zero. Mathematically, the relationship between the GLBB formula and the GJB term is obtained by the following equation. V equals V0 plus A times T, where V equals velocity, V0 equals initial velocity, A equals acceleration, velocity is zero, then equals V0 plus AT equals 0 plus A times T equals A times T. Get equation 1. Call the distance equation in GLBB, which is as follows. S equals V0 times T equals half E times T squared equals 0 plus half times T squared equals half times T squared. Get equation of 2. The motion in free fall has a vertical direction. The distance symbol S can be replaced with height symbol h, and the acceleration can be replaced by g. Thus, equation 1 and 2 are as follows. V equals G times T, where H equals half times G times T squared become T equals root 2 H per G, and P equals G H root 2 H per G becomes C equals root 2 times H times G. Final velocity of an object in free fall is influenced by the height and the acceleration due to gravity. And what are the applications of free fall motion in everyday life? The application of free fall motion in everyday life, namely 1. Measure the height of the building. 2. Measure the depth of the pool. In order for your understanding to be more honest, let's try to work on the following example problems. Example problem 1. Pharaoh and Fairy are on a hill. Not far from their location there is a ravine that is not too deep. As a precaution, they want to know how deep the cave is. To measure it, Fairy threw a rock into the ravine, and Pharaoh measured the time it took for the stone to reach the bottom of the ravine. From the calculation result, the time optioned is 3 seconds. How deep is the ravine that Pharaoh and Fairy have measured? Discussion. Now, T equals 3 seconds. Later, solution. Height equals half times G times T squared. Half times 10 times 3 squared equals 45 meters. Example problem 2. A coconut fell from a height of 5 meters. How fast in the coconut when it is the ground? This question. Now, height equals meter, 5 meter. One set. V. Solution. To find the velocity when it hits the ground, use the following equation. V equals root 2 times g times h equals root 2 times 10 times 5 equals root 100. The root of 100 equals 10 meters per second. So the speed at which the coconut hits the ground is 10 meters per second. That now what is can explain. Hopefully this will be useful for all of us. Thank you. Goodbye. Wassalamualaikum warahmatullahi wabarakatuh.